In this video, we're going to talk about 3.1 Objective 1, where we construct and interpret frequency tables. We're going to start off with some basic questions and definitions and properties and things. And then we're going to get into some problems where we actually do some computations. And when we get to that point, then I will switch the view and I will show you my calculator while I work through the problems with you. So let's just start off with the first few questions here. What is a frequency table and how does it show categories and frequencies? So a frequency table has two columns. The first column lists all of the categories of data, and the second column lists the frequency of each category, which is the number of data values in the category. So that's option A. What is the purpose of binning? And give an example in which it is useful. So the purpose of binning is to analyze the frequency of quantitative data grouped into categories that cover a range of possible values. A useful example is grouping quiz scores with a maximum score of 40 points with 10-point bins. The first bin would consist of scores 0 through 9, the second 10 through 19, and so on. So that would be option D. And our third question here, describe whether the following statements make sense or is clearly true or does not make sense or is clearly false, and explain your reasoning. I made a frequency table with two columns, one labeled state and one labeled state capital. That doesn't make sense because neither of those is the frequency. So the statement does not make sense in a frequency table. One of the columns lists the frequency of each category, which is the number of data values in the category. The table described in the given statement does not have such a column. So there we go. So now I'm going to switch views as we actually I'll switch views so you can see the calculator here. 1 second. All right, so question 4 says natural births randomly selected from hospitals in a highly populated region occurred on the days of the week from Monday through Sunday with frequencies of 53, 66, 71, 56, 54, 45, 44, 55. Let's see, 1, 2, 3, 4, 5, 6. Yeah, okay. There we go. 53, 66. I just thought that there weren't enough numbers there for a second. 56, 55, 44, 55. There we go. And then we want to find what's called relative frequency. So to find that, we're going to have to add everything together here to get our n. So our n is the sum of all of our frequencies. We're going to have to get 53 plus 66 plus 71 plus 56 plus 55 plus 44 plus 55. And that's going to be 400. So now we're going to, and they tell us to round to 2 decimal places as needed. So I'm just going to go into my list here. I'm going to show you how I would do this. Stat, edit. I'm going to put in these data values, 53, 66, 71, 56, 55, 44, and 55. I'm going to come over to list 2 and I hit enter on top of it, and I want my list 1 divided by my frequency, my sum of my frequencies, my n is 400, and I'm going to round these to 2 decimal places as needed. So this is 13%. That is going to be 17%. That's going to be 18%. Sorry, I should be going to the nearest hundredth of a percent here. So 13.25%. 16.50%. 17.75%. Exactly 14%. 14.00. 13.75%. 11% exactly. And 13.75%. Now, what I would be interested in seeing, especially if I had done any rounding, would be to make sure that this 13.25 plus this 16.50 plus 17.75 plus 14.00, 13.75 plus 11.00 plus 13.75. Let's go back here. That's supposed to be a decimal point. So that should add up to 100%, and it does. So let's keep going. I think that's pretty safe to say we didn't make a mistake there. All right, now heights of respondents were recorded as house, the digit of the height from 31. One randomly selected respondents are listed below. Construct a frequency distribution with 10 classes. Based on the distribution, do the heights appear to be estimates or actual measurements? How many zeros do we have? 1, 2, 3, 4, 5, 6, 8, 9. And then we have 1 with a 1, 2, and then oops, 3. 2 more, and then 2, 3, 4, 5, 6, 7, 8, 9. 2, 0, 2, and 2. All right, and then based on the distribution, do the heights appear to be reported, or I guess that means rounded or actually measured? So they appear to be estimates because there's disproportionately more zeros and fives as the last numbers. So it looks like they were rounded values. Analysis of 50 train derailment incidents identified in the main causes listed below, where T denotes bad track, E denotes faulty equipment, H denotes human error, and O denotes other causes. Construct a frequency table and include a column for relative frequencies expressed as percentages. What's the most common cause of derailment? So we're going to have to count all of the T's here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See if I missed any. Looks like that's 12. And then faulty equipment would be my E's. Switch my color here to maybe red. E's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Switch my color again to maybe green. The next one, human error, would be H. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And everything else left should be an O. Let's pick a, oh, I don't know, brown for that. 1, 2, 3, 4, 5, 6, 7. You see that I didn't miss any. They were all checked off the list this way. So when I go back here and add them all together, 26, 33, 40, 50. And that's exactly what I should have gotten because there's my N is 50. So now I'm going to take and I'm just going to compute them. 12 divided by 50 is going to be 24%. It's going to be doubling these numbers to turn them into percent. So that's going to be 28%, 34%, and 14%. Let me show you that. 12 divided by 50 is 24%. 14 divided by 50 is 28%. 17 divided by 50 is 34%, and 7 divided by 50 is 14%. The reason that I knew that it was going to be, if I want to change it to a percent, that means out of 100. So to do that, I needed to multiply the denominator by 2. So I need to multiply the numerator by 2. That's how I did that so fast and said that was 24%. So, all right, so the most common here we see is human error is 17 out of 50 or 34% of the time. So let's get back to my blue that I like. All right. The accompanying data showed the ages of many Academy Award winning male actors at the time when they won the award. Through 2022, construct a frequency table of the data using bins 20 through 29, 30 through 39, and so on. What ages are most common for the winners? Data is down here, so I need to look for things in the 20s first and mark them off the list and count them. Let me go column by column. 1, okay. See if that holds. may have just overlooked something. 30s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 31, 40 through 49, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Now let's look at 50 through 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's look for the people in their 60s. 1, 2, 3, 4, 5, 6. People in their 70s. 1, and people in their 80s. 1. All right. And the most common age for uh, Academy Award winning actors is 40 to 49. So they're 40s. And that's it for this video. We'll come back next time and we'll talk about 3.1 Objective 2. We'll see you for the next video.